Okay. Hi, I am Joydeep Singh, the instructor of the course Calculus upon Real Variable. Course number is MA 49. Today I will discuss the week 0 assignment of the course. Okay, let's start. Okay, so this is the assignment 0. So the first question is the set n union q is countable or uncountable. N is the natural number, q is the rational number. So what is countable? Countable set means if there is a bijection from the set of natural number to that set. So n itself, so this is a n natural number. Okay, n is countable, this is by definition. And q, that q is also countable, so that q means q you can enumerate so that there is a bijection from the natural number to that set q. For that q you so take the sum at first positive rational number, so then q you can represent 1, just write 1 2 3 4 like that, and divided by everything by 1. Now I can write it this 1 2 3 4 divided everything by 2 like that, and go on this side also, means there will be 1 by 3, 2 by 3, here will be 3 by 3, it will be 4 by 3. Now do this diagonalization from this, then take that one. So this is the sequence. So first a1 will be this 1, a2 will be 2, a3 will be 1 by 2. So that sequence, then you can find a bijection from natural number to this rational number. So q is also countable. Okay, and now you can prove that, so n and q both are countable. You can prove that union of two countable set is countable. So then by so this is a property that union of two countable set is countable. So this you can prove by what? Take just as a is, suppose that a is countable, then you can write it as a1, a2 dot this, and a b. Suppose this is also countable, then you can write b1, b2 dot this. Now what you will do? Just define a function f from n to a union b. Take just first 1 goes to this a1 and 2 goes to this b1 like that, 3 goes to again a2, 4 goes to b2 like that. Then you will find a bijection from this union. So union of two countable set is again countable. So then by this n union of q is countable. Okay, so now move to the next question. What it is saying, x is pi by 1 minus pi. You have to tell that it is irrational or rational number. We know that pi is irrational, right? This pi is irrational. Then you have to tell what will be the pi by 1 minus pi. 1 minus pi will be again irrational, but division of two irrational number may not be irrational. So you have to prove this, that is this irrational or irrational. So suppose we claim that this is rational, then we will arise at a contradiction. Okay, So suppose this is irrational. Suppose pi by 1 minus pi is rational. Then what? Then we can write pi by 1 minus pi as p by q, right? Where p belongs to z and q belongs to n. Right? So then what will be, then cross multiply? So it will be q pi equals to p minus p pi, right? Or it will be q plus p into pi equals to p, or then pi will be p by q plus p. So note that here q not equals to p. Suppose here, do it here. Suppose q equals to minus p, then what will happen? Then pi by 1 minus pi, it will be minus 1, right? So this means what? Minus pi equals to 1 minus pi. So sorry, so this imply 0 equals to 1. So this is not true, right? Contradiction. So q cannot equals to minus p, and this is again, as p is rational integer and q plus p is again integer, so this is a rational number. So it's, if we are assume that this is rational, then we are arise at that pi is rational, so which is a contradiction, as we know pi is irrational. So pi by 1 minus pi cannot be rational, right? So pi by 1 minus pi is irrational. Okay. Now come to the next question. What is saying? Let a be a rational number. Then you have to say a 2 to the power a is always a rational number or not. It's true or false if a is a rational number. So this will not be always true. Means suppose a equals to 1, then what happen? 2 to the power a 1, it will be 2 to the power a means 2 to the power 1, it will be 2. So this is rational. And now take a to be half, then what will happen? 2 to the power a means 2 to the power 1 by 2. This is square root of 2. That you know, this is not rational, right? So this is irrational. So for a rational number a, 2 to the power a is not always rational number. So this is false. Okay. Now come to the next question. What it is? If a be a prime number, then it's saying that a square plus 2 is always prime or not. So means, is it true or false? Take some prime number 2 at first take. So suppose a equals to 2. What will happen? Then a square plus 2, it will be 6, right? So this is not a prime number. So this is again false. Okay. Okay, now come to the fifth question. What it is saying? If p is a prime number and p divides ab, where ab are natural number, then p divides a or p divides b. Okay, so this will be true. We will prove this. So how to prove this? So if p divides a, then we are done. We are done, right? And now if suppose, so this is case 1. Case 2. Suppose p does not divide a, means which will imply GCD of p and a, it's 1. So what is the meaning? Means there exist x and y which are integer such that px plus ay equals to 1. Okay. So number it by 1, multiply 1 by multiply 1 by q or b, then what happens? It will be pbx plus aby equals to b. Okay, now look, as so now look at that, p certainly divides pbx, right, because there is a factor of p, and as p divides a, so p divides and p divides aby, right, because p divides a, so p divides pbx and p divides aby, so implies p divides this sum, right, pbx plus aby. And what is this? This is b, so if we number it by 2, so by 2 we get p divides, or suppose this p does not divide, then we get p divides b, right? Okay, so if p does not divide c, then we get p divides b. So we get, if p divides ab, then okay. So here we have p does not divide c, right? As p divides ab, so here this will, as p divides ab, so that's why p divides aby. So imply p divides pbx plus p divides aby, so by 2 p divides b. So if p does not divide c, then we get that p divides b. So we are done, so it will be true, right? Okay, now come to the next question, problem number 6. What we have to prove? Suppose f is a continuous function from ab to r, then we have to prove that f is bounded. So f is a, so we have to show that f is, it's true or false. We'll prove that this is true, means if f is a continuous function and this ab, this is a closed intervals, then we will prove that continuous function on a closed interval will always be bounded. Okay, so f ab to r, this is continuous. We have to prove that f is bounded. Okay, so suppose f is not bounded, suppose f is not bounded, then what will happen? So we will get a sequence, so then there exists a sequence xn in AB such that mod of f of xn is greater than n for all n, right? And xn is a sequence which lies in closed interval AB. So this is a bounded sequence. So by Bolzano-Weierstrass theorem, it has a convergence subsequence, implies there exists a x Rn such that x Rn, which will belongs to, again belongs to AB, such that x Rn converges to L, and L will belongs to AB because AB is closed. Okay, now what will happen? As xn is x Rn, this subsequence, again we have, this is subsequence of the original sequence xn, right? So for x Rn, this will again hold, right? So we will get f of x Rn is greater than Rn, right? And Rn is a subsequence, means it is an increasing sequence. So Rn, as Rn is a subsequence, so Rn is the indices of the subsequence, so Rn is always greater than n, as Rn is increasing. So this is by the definition of subsequence. Okay, so what we will get, f of x Rn is greater than n. So what we will get, as so we get a bounded sequence for which that f of x Rn, this is greater than n, right? And xn is a sequence which converges. So what we will get, f of implies, so this is true for, right? So then we have to show that we will arrive at a contradiction, right? So you have to show that this cannot happen. So what will say that, so as xn is a convergent, this is a xn as, and note that f is given to be continuous, as x of Rn this converges to L, and as f is continuous, right? So which will imply f of x Rn will converge to f of L, right? Okay, so which will imply that, but this is a finite number, right? So this is a, if we converge, this will be convergent, right? So this will be belongs to in R, but this is saying that f of x Rn is not convergent, right? Means this is convergent, means f of x Rn, this sequence should be bounded, right? Because every convergent sequence is bounded. But from this, suppose this is 1, but from 1 we get f of x Rn is unbounded. So which is a contradiction, right? So means f should be bounded. Right? Okay. Okay, now come to the next question. What is saying? For a sequence xn, if xn converges to x0, and for any function, is it true that f of xn will converges to f of x0? So this is not true for in general function, but this will be true for continuous function. Here continuity is not given, right? So this will not be true. So what will be the counter example? So take f to be, what will be, take f to be 1, f of x, if x belongs to q, then we will define it to be 1, and 0 if x belongs to r minus q. Okay, now for n, suppose x0 belongs to q, then by the density of the irrational in the rational, density of the irrational in real number, so there exists xn sequence from Rn minus q such that xn converges to x0, right? And okay, then what will happen? So as xn is irrational, so f of xn, what will be the value of f at xn? So it is 0, right, for all n. And what will be the value of f of x0? As x0 is rational, value is 1, right? So what imply? So this sequence cannot, so this is a constant sequence 0 which cannot converge to 1, right? So this shows that f of xn does not converge to f of x0, right? So this is false, right? Okay, we have done. So the last one, if is continuous, then f is bounded, it's true. Okay. So question 7 is done. Now come to the question number 8. What it is saying? If f and g are two functions on R, Then the domain of fg means is the product of two functions, is same as domain of f union domain of g. It's true or false? So it will be false, means domain of fg will not be domain of f union g. So let's see by some counter example. So take f of x equals to 1 by x, where the domain is 0 and 2, and take gx to be 1 by 1 minus x for x belongs to 1 2, right? So these are two functions. So when we will talk about fg of x, so we can only talk about where the both the functions are defined. So this will be the fg of 1 by x, it will be the x into 1 minus x for all x belongs to 1 2. In the common region we can only talk about the multiplication of two functions, right? So what is the domain of, so domain of fg, it's 1 2, right? But what is the domain of f union domain of g? It's 0 2 union 1 2, it's 0 2, right? So these two are not equal, so this is false, right? Okay, so question 8 is done. Now come to the question number 9. What is saying? Consider the function g, so this is gx equals to e to the power f of x. Okay, then you have to find the range of g. Note that exponential function, it's always positive, right? So what will happen? So means this range as e to the power x is always greater than 0 for all x, and what f is a function from R to R, right? So range of g will be contained in this set, right? X such that x greater than 0, because it may not be equals, right? Because if you take some f equals to some constant function, then g will be again constant, so range will be some positive 1 point, so it will be subset. So from here we can say that range of g is a subset of x belongs to R such that x greater than 0, right? Okay, so question 9 is done. So now come to the last question. What it is saying? If f is a continuous function, then 2 to the power fx is also continuous function. Okay, so this will be true. Okay, so the last one, so it is true, 9 is true. So 10, it will also be true. So f is continuous is given, f is continuous, and define this function g equals to 2 to the power x, and this g of x equals to 2 to the power x. This you can prove that this is also continuous, g is also continuous. This you can easily prove by sequential criteria. Suppose xn converges to some x, then by the limit 2 to the power xn it will converge to 2 to the power x, right? So gxn will be converges to g of x, so g is also continuous. So this is easily proved by sequential criteria, so g is also continuous. And now composition of two continuous function is continuous. This is one property, and this you can easily prove that composition of two continuous function is again continuous. Right, then what will be the 2 to the power fx? Then what will be the g compose f of x? So it will be g of f of x, right? Means 2 to the power f of x. So this is, so 2 to the power fx is a composition of g and f, where g and f both are continuous function, so which will imply 2 to the power fx is a continuous function. Okay, so we are done. So week 0 assignment is done. Okay, so let's stop for today. Okay, bye.